One of the biggest misconceptions I've found about forces, especially things like gravity, is that heavier objects fall faster than lighter objects. That's always key. And it's common sense. Now, the best way I can describe this is thinking about parachutists jumping out of a plane. Now, I've got a parachute on my back and I jump out. I still weigh the same whether the parachute is open or shut. But obviously, when the parachute is shut, I fall a lot faster. When I open the parachute, there's a bigger force on that parachute. It captures more air. There's a bigger push upwards, reacting against the gravity pulling me downwards, and therefore I slow down. I don't travel as fast. Easy way to show this with children is to take a flat sheet of paper and drop it. It'll fall at a very slow rate. Take that piece of paper, scrunch it up into a ball. Still weighs the same, it's the same sheet of paper. Drop it, see it falls a lot faster. You can see there it's the surface area, the shape that matters, because with a wider surface area it can capture more air, it gets a bigger push upwards than when it's a ball. Air can't push on it, so it falls at a quicker rate. So, have any of you been ice skating? Are any of you actually any good at ice skating? Good, right, some of you are, some of you aren't, okay? I'm not particularly good, so when I go ice skating, I usually hold on to the side like this, okay? Now, when I hold on to the side, I push in that direction. What direction do my feet go? The other direction. Good, they go backwards, don't they? So I have a push in that direction, have an equal and opposite push in the other direction, and I usually fall down.
When you pushed against the wall, that was the push. So, like the rocket, the fire is the push, and then the rocket goes in the opposite direction.
That's brilliant. Okay, do we all get that? Yeah. So this is how rockets work. More force going down means our rockets can go up. Now, when I hand these bottles out to you, you're going to be using one as your rocket engine. It's where I'm going to put water in, and what I'm going to do is pump loads and loads of air inside of it. And all that air and water comes rushing out and pushing downwards. And what way is the bottle going to go? Upwards. That's a good idea. You've all been on the tube, bus, car. And you know when it accelerates or goes around a corner, you feel yourself being pulled back into your chair or being pulled in different directions. Bizarrely, that's G-force, okay? It's an accelerating force. It's gravity. Artificial gravity. That sounds strange. At the moment, you're feeling the force of what we call 1G, 1 gravity, okay? But if you accelerate, you can feel more than that. Now, your poor astronaut, your egg here, when it's shooting up, it accelerates very fast. It's got to get pushed back. This means it's got to feel a lot of G-force, okay? So you've got to make sure your astronaut can withstand that, okay? So you make a big, long tube. Over. 3. So. Whoa! Well done! Whoa! That was the highest, I'm not gonna lie.
When it went down, it came down really, really fast and dented it here.
So you can see here, yeah, it's all squashed up, hasn't it?
Yeah.
It only has to take a little bit of energy out of the crash to mean the safety between the egg cracking or not cracking, or the same with your head. Does that make sense in a crash?